Another type of categorization of impurities is based on its relation to the API. Related impurities are structurally similar to the API and arise from its synthesis or degradation pathways. They will, if we think back to the previous categories based on origin, be mostly organic impurities. On the left, the structure of VOR is shown. The molecule depicted in the upper right corner of the slide resembles very closely VOR. It is an oxidative degradant of our API and is thus a related impurity. Attached to this video, you'll find the forced degradation pathways for VOR. Unrelated impurities, on the contrary, originate from external sources, unrelated to the drug's synthesis or degradation pathways. They can be introduced during the manufacturing process of the drug. A typical example is the presence of residual solvents, but unrelated impurities can also originate from cross-contamination from equipment or contaminants present in raw materials of excipients. If we take a look to our VOR casus, we identify different compounds as unrelated impurities. There may be impurities present in the potassium iodide batch. Toluene can also be identified as an unrelated impurity since this is a residual solvent. Now we have categorized impurities by their chemical class and by their relation to the API molecule. Another way of classifying impurities is by assessing whether they are identified, or in other words, the structure is fully known. Identified impurities are precisely known and chemically characterized using techniques such as chromatography and spectrometry. The chemical structure of the impurity is known. Unidentified impurities, on the contrary, are present but not yet characterized. Their chemical structure is not known. Note that this does not mean that the unidentified impurity must be a completely new molecule. It might just be that the impurity is, for example, a reagent from the synthesis cycle, but the identity could not yet be determined with the available techniques. At a later stage, unidentified impurities can become identified. To recapitulate, we now have discussed three ways of characterizing impurities, either by their class, their relation to the API, or whether their structure is known. Finally, there is a last, commonly used classification. Specified impurities are the ones we expect to find in the drug. We pay special attention to these using detailed methods for analysis. Each specified impurity has its own acceptance criteria or specification limits. We analyze these impurities consistently every time. The results are also documented in the analysis certificate of a newly produced batch. Let's take a closer look to the last step in the synthesis of VOR. It could be possible that this last reaction from Roman number 4 to VOR is not completely quantitative. Some of the intermediate number 4 might still be in the final API. Since the presence of this intermediate is expected, it can be seen as a specified impurity, and it will be analyzed every time. On the other hand, unspecified impurities are impurities which you do not expect to see in your batches. Their structure and potential origin might be known, but due to the particulars of the manufacturing process or the formulation or packaging and storage conditions, you do not expect to see them. If, for example, the first VOR synthesis reaction of starting material 1 and 2 is a complete or quantitative reaction, molecule 2 is not expected to be present in the end of the manufacturing process, and will thus be an unspecified impurity. In general, unspecified impurities are accepted to be present below a general identification threshold. Once an unspecified impurity is observed in a real-life batch above the threshold, it is obligatory to further identify this impurity and evaluate its toxicity to get its own specification acceptance limits and thus become specified. In the later module, we will come back to these thresholds. It is clear that classification of identified and unidentified impurities and the specified or unspecified impurities are closely linked to each other. Let's now combine these classifications in a table to try and visualize their relation. On one side, an impurity can be either identified or unidentified. We can put these groups in the first column of the table. On the other side, an impurity can be specified or unspecified. We'll put these categories on the top row. Now we've created 4 groups. The first group are the specified and identified impurities. You know the structure, and you know you have to test for them against a defined limit. As a synthesis reaction from Vor is known, all intermediates which are likely to be present at the end of the synthesis reaction are specified and also identified, like as we discussed previously, Roman number 4, for example. The second quadrant of our table are the specified but unidentified impurities. For these impurities, you need to quantify their presence, but you do not know the exact structure. Sometimes the only thing you can say is that the impurity elutes after 3 minutes from the column. You will evaluate the level of impurity presence in the sample against a historical defined limit. These impurities are very rare. The third part of our table contains the unspecified but identified impurity. These other detectable impurities, abbreviated as ODIs, are potential impurities with a defined structure but not known to be normally present above the identification threshold. But why are they then identified? Let's consider the forced thermal degradation of VOR. These impurities are formed in extreme conditions. VOR is placed in an oven under 100 centigrade for 48 hours. In real life, these are not the average storage conditions for the drug, as you might expect. All the impurities formed after the forced thermal degradation are identified, but not all are found in real-life samples. If these impurities are below the identification threshold, they will be considered as unspecified but identified impurities. The last category are the unspecified and unidentified impurities. Since an impurity in this category is unidentified, specific tests, acceptance criteria, or regulatory limits for its presence are a challenge. We will quantify these unidentified impurities and test them against a general identification limit, for example, taking the API as an external reference to which the unidentified and unspecified impurity is quantified and evaluated. In these videos, we tackled different ways of categorizing impurities. We started with a categorization based on chemical class with organic and inorganic impurities, residual solvents, and other impurities. Then we evaluated the relation to the API with related impurities and unrelated impurities. Another way of categorizing impurities is whether they are identified or not, and the last categorization method is whether the impurity is specified or not.